Welcome to the CANA Connection Podcast. On today's podcast, we have an internal CANA team member joining us. It's Margaret Hauser, and she is our Senior Operations Research Analyst, or I should say one of our Senior Operations Research Analysts here at CANA. And then my co-host for today is Kassie McRostie. She is our Digital Media Coordinator, and I'm going to let her run with today's interview or session talking about CANA Core Algorithms. So without further ado, Kassie, take it away.
Hello, everyone. Welcome to the CANA Connection Podcast. I'm Kassie, and I'm here with Margaret today. We're going to talk a little bit about CANA Core Algorithms, which, Margaret, you are an expert in, and you know all things. So we'll kind of jump right into it. We know your name, obviously. So your role at CANA, Senior Operations Research Analyst, kind of tell us how this CANA Core Algorithms came about and what is it, basically.
Yeah. Hey, Kassie. Hey, Koa. I'm happy to be here. CANA Core Algorithms started from an idea. We had a little bit of downtime in between projects, and there's this really cool tool that we have to solve a problem. This is a particular solution set. And it started as a student's master's thesis. And so this code was kind of written by a master's student in Java, which is not a typical language that an OR master's student uses. They usually use something like Python, which is a little bit simpler to write in. And they created this really cool algorithm implementation, and it ran really fast. And then as we adopted it, we added additional features and we added other components to it and other checks and assessments. And so we basically kind of grew this basic code to this massive project. But the code itself basically got really messy because it was written by analysts and not by software developers. CANA Core Algorithms was kind of founded with this refactoring of the code. And it sounds relatively simple. Let's just reorganize it. But in essence, it's a very complex algorithm. And so to implement it differently took a significant amount of time and effort. And what we found, which was awesome and what we would have expected, is that we saw something like a 20 times speed up in solution runtime and all this stuff. But this was kind of the foundation for CANA Core Algorithms of we have this algorithm, this really good solution. And we invested some of our own time to make it better. And now it's much more adaptable to address other clients' problems or new clients' problems. So basically the point of CANA Core Algorithms is we have some really cool algorithms. We have some really cool solutions. And these solutions can be generalized for a set of problems. So it's not necessarily bespoke to a single client, and it can't be used anywhere else. We can kind of tweak a few components. Maybe we take out this feature or we add this other feature. And now we have a tool that can solve the same client's different problem, a new client's problem, or a completely new project. So CANA Core Algorithms is designed to take these cool solutions that we have and maintain them and make it easy to tailor these solutions to other problems.
So it's basically you have a good foundation of an algorithm, and then it's very customizable. And that was going to be my next questions are like, what are some of the key factors, I guess, that make the CANA Core algorithms attractive to customers? Can you explain some of those key factors of that?
Yeah, that's a great question. Not all algorithms that we have are considered a core algorithm. So we have intentionally selected, we have a group of APs and we make assessments on algorithms that we have. So solutions that we currently have that we've invested time in. And then the ones that we select to be core algorithms, we deem them to be easily tailorable or generalizable to other problems that we see. So the biggest draw for this is if we have a problem, a client comes in with a new problem. Hey, I've got this problem. We have something that's effectively off the shelf that we can use. So this saves us a tremendous amount of development time. This saves us, we can have much quicker deadlines. We can get the results of the analysis much faster because we have something that's already designed to handle a problem like this. Now, we do expect to have some tailoring. Maybe we need to add in rail as a method of transportation for this logistics problem, or maybe we need to take out ships as a method of transportation for this problem. So there are some tailoring components, but what it does is it dramatically reduces the development time from maybe like a year to a couple months. And that's really good for our clients because they get their answers sooner. And it's good for us because we actually get to work on the interesting part of the results and not necessarily building out the tool itself.
Yeah. So it's really a win-win for everybody in the end.
Yeah.
Could you give us maybe like an example of how a CANA Core algorithm has been used in, with one of our clients, or maybe, somebody you've worked with?
Yeah. So the that kind of foundational algorithm that I talked about, it solves complex logistics network problems. So effectively, we have a bunch of things that need to move around. Let's call them commodities. We have a bunch of commodities at different locations, and we have all these different ways that we can move it around. We can move it in the air, we can put it on a ship, we can put it on a railroad, we can move it all around. And with the refactoring of the code, what's been done is we have documentation, and it's basically organized really neatly. So then we had a client come and say, hey, we want to add this feature to it. And to add this particular feature, which basically limits the capacity of vehicles at a given location, to add this feature to the old version of the code, the stuff that hadn't been kind of revamped and cleaned up, would have taken a tremendous amount of time and probably would have slowed it down extensively. However, because we kind of had done this refactoring, we have this algorithm, and granted, the client was already using that algorithm, but we were able to kind of tweak it to address this new question that they had. And so rather than building out a whole new tool, or rather than spending an extensive amount of time to go through the old piece of code that we had, we were able to kind of add in this feature and then address the problem.
That makes sense. I was going to go into how it better our client, but I feel like we kind of covered that with just like the time and stuff. So
yeah, I mean, one other thing to add here is that, CANA is investing in these tools that we think are really valuable. We're investing in these solutions. So we're codifying the knowledge. We're kind of making it a more formal solution so that it is easily digestible to other clients. So in this way, CANA is investing the time in these solutions because we do see such significant value, and because we expect that we'll be able to multiply that. It'll be a force multiplier, if you will, for our clients moving forward, either for existing clients or for new clients, for the same problems that we have or for future problems.
Yeah. Koa, did you want to go into the Powered by CANA Analyst?
Sure, but before that, I have stupider questions. No, I have a simpler things to ask that are. So you threw out at the very beginning, we're starting to talk about the CANA Core algorithms, and one of the reasons for like a client to switch to it, or not switch to it, but to utilize our Powered by CANA Analytics, which is the expertise of our people and everything like that, which I'll let Margaret talk more about if she wishes to. But so I think you were solution runtimes, and you said implementing our CANA Core algorithms gave like a 20x improvement, right? But like, what does that mean? Like, how long was a typical runtime for one particular situation, and then what did it become afterwards? Obviously, an improvement, but like, how drastic of improvement is that? Because in a vacuum, like if something took 20 milliseconds and you took a 20x off it, I'm like, well, I don't know if I recognize that, but I'm sure that it's not within that type of scope. It's something larger than that. But I don't know how it calculates to the normal person that would hear that.
Yeah, and one thing to point out here is CANA Core Algorithms is basically our analytic solution inventory. It's our shelf of solutions, and we can pull one off. So this particular solution that we've pulled off, it solves a complex logistics network. How do we move all this stuff around? And the big use case would be, let's see, I think I stopped a run on the legacy version of the code. So that's kind of the old stuff before it was refactored at like 40 hours. I stopped it because I wasn't going to run to the end. So it maybe got, I think, 30 to 40% of the way through. So it was not done. So it had generated solutions. The way that this algorithm works is it generates a lot of solutions and then it picks the best one. Right. And there's obviously a complex information transfer throughout this using a genetic algorithm to develop a good solution. Whereas the speed up took less than 3 hours. I think it was 2.5 to 10.
Yeah, that's significant.
So it's very significant. And a lot of this has to do with when you get software developers in to refactor code, they're really good at their jobs. So of course it's much faster. And then also the legacy code was developed from, I don't want to belittle the legacy code because the algorithm is exactly the same. It's just implemented differently by somebody whose job it is to do this really well. So in terms of the scope, what this really means is, we're not frequently running 2.5-hour scenarios. That was a very large scenario. For me right now, I'm actively using this model and I'm, maybe running a design of experiment, or I'm tweaking some of the inputs to see how they affect the output metric. And if it takes me a minute to run, that's really easy. I can just, kind of iterate through. But if it takes me 30 minutes to run or an hour to run, there's only so many trials that I can analyze. And so that kind of limits my ability to explore the solution space, or I have to run it over a long period of time. So set up a program to run them sequentially over several days. And in that case, that takes a lot of computing power away from other projects that I'm working on. So in terms of speeding up, it also, gives us more time to explore more interesting questions. And so it kind of reduces the constraints that we have on solution exploration.
Yeah, because time is the thing we can never get more of, right? Especially if you have timelines to fit within and you have to work within stuff. So yeah, that's a huge difference. And thank you for giving that example as a more cohesive narrative. It puts things into perspective a lot better for how the core algorithms can affect research and development and or testing and stuff like that you guys are doing. Now, I know that we have multiple CANA Core Algorithms, hence the plural at the end of it. I know we have two main ones right now, but we're constantly, or I would assume, either improving those or looking for others to implement as standards that we have as our go-to. Do they have, how would you bucket the two that we have?
Right now, actually, they are both genetic algorithms, so that's very exciting. So the two main models that we have, one of them is called the distribution network model, and that's moving stuff around. And the other one is the Nexus model, and it has to do with autonomous defensive. But they're both basically, they generate solutions, and then based on the quality of the solution, how good was that solution, it informs us moving forward. So it's kind of like artificial intelligence in that, we're kind of giving the algorithm the tools to say, okay, that was a good solution, let's look for solutions like this, or that was a bad solution, let's not look for solutions like that. And so in that way, like those two algorithms, they take a specific question and they solve it. However, there's another algorithm, if you will, it's more so a code base, so it's not necessarily novel, whereas these two kind of solutions are novel. They're novel solutions. The other one is a design of experiments. So it takes in and it factors things and how do we run a design of experiments. And so this is relatively straightforward. Many people can implement a design of experiments, but this is just our flavor of it so that we have an off-the-shelf thing for clients if we want to run a larger design of experiment.
So I have a question that comes off of what you just said, because I think it's a term that I hear all the time, but I'm not even sure that I completely understand. What does novel mean?
Novel it's like new, it's bespoke. So with design of experiments, for example, this is, you can read a textbook and it says you can set up a design of experiments like this. You have variables X, Y, Z, and this is how you vary them, and these are the different trials, and then this is how you can analyze the results. So it's codified, if you will. Like it's a step-by-step procedure that we can follow and we know. Whereas, the distribution network model and the Nexus model, these they stem from models that are common. So ant colony optimization is one of them, and then a different genetic algorithm, and I'm blanking on the name. But there are these general concepts of, okay, this is how we implement these genetic algorithms. But what we've done is we've actually said, okay, we have this feature, so now we're going to build this feature in, and now this algorithm is going to kind of incorporate it. So initial implications of ant colony optimization didn't use, let's say they don't use multimodal transportation. So different types of, ships and aircraft, different types of ways to move things around. But we've added that. So now you can move it around with these different ways. And so that informs the algorithm itself. So it's novel in the sense of what we've done, the exact thing that we've done, no one else has done that with ant colony optimization. And the same with the Nexus model. with that type of genetic algorithm. No one else has done that implementation of it.
So that helps me with my idiot brain that I have.
Non-developer brain.
There's so many things bouncing around in there, and I hear terms like you had mentioned earlier before we actually started recording. Dr. Hauser said, we have all these acronyms that bounce around all the time, just internal to the company, and because we have a lot of government/military clients, everything like that, and it's acronym city. It's everything there. And the reason we were talking about it was because I was trying to get everybody's titles under their name in the podcast here, and her title is relatively long, so I had to truncate senior down to just SR.
I would like to ask you, Margaret, where can people find more about the CANA Core algorithms, or if they want to contact you about learning more, or if they are a client searching for this, where can they contact you at?
Yeah, my email, I believe, is available on the CANA website, and Koa could actually probably speak to getting where can they access the materials, because I would direct them certainly first through the CANA website, and then, if they want to get in contact with me and have specific questions, I'm always available by email.
Yes, for those out there that are interested, you can head on over to our website, canallc.com. We will have, obviously, if you search around there, there's going to be some blog posts that probably talk about the CANA Core algorithms. There are sections of the website that will be evolving over the course of time here to talk more about the CANA Core algorithms. You can also find on our website events and articles that involve our people, the rest of Team CANA, and learn more about the Powered by CANA analytics and what that means. And that's just our way of kind of branding our people and the expertise and knowledge that they bring to the table. So whenever you see that, think of us. And I'd like to thank Dr. Margaret Hauser for joining us today to talk about the CANA Core algorithms. We're going to have more chat about the CANA Core algorithms in future podcasts. We'll probably talk to Mr. Walter Grange and probably Connor McNamore at some point in time. This is Koa Beam, the producer for the CANA Connection Podcast, signing off for Kassie McRostie, Margaret Hauser, and the rest of the CANA Connection Podcast crew, reminding you to analyze, assess, and execute, and we will catch you next time.